Here we have a pre-calculus problem. Okay, let's go to the question. Evaluate log base 2 times square root of 2 of 1 over 256. That is, we have to find the value of this logarithm. Okay, let me write the logarithm as it is. That is log base 2 times square root of 2 of 1 over 256. Okay, let me assume the value of this logarithm as x. Then it is equal to x. Now we have to find the value of x, which represents the value of the given logarithm. Okay, now this equation is in logarithmic form. Now to solve for x, we have to convert this equation to exponential form. How do we have to convert this equation to exponential form? For that, we have to consider the logarithm along with the base 2 times square root of 2 over here. Now we have to move this logarithm along with the base 2 times square root of 2 to the right side of the equation. When I move this logarithm along with the base 2 times square root of 2 to the right side of the equation, we have to ignore this logarithm. We have to consider only the base 2 times square root of 2 on the right side. The value which already exists on the right side, that is x, will become the exponent of this base. Now on the left side, we have 1 over 256. Okay, we know that 256 is a power of 2. So we can write this 256 as 2 to the 8th power. Then on the right side, we can write this for 2 times square root of 2 as 2 times this square root can be written as exponent. In that case, I am getting the exponent 1 over 2. So raise it to the power of x. Okay, now what we can do is we can move this term 2 to the 8th power to the numerator. Okay, when I move this kind of powers from numerator to denominator or denominator to numerator, the exponent will change its sign. So it's already positive 8. When I move this term to numerator, it will become 2 to the negative 8th power and it is multiplied by 1. Still I'm getting 2 to the negative 8th power. Okay, on the right side, we can consider the 2 over here. What is the exponent of this 2? Actually, there is no exponent for this 2. We can assume there is exponent 1. So whenever there is a number without exponent, we can assume there is exponent 1. Okay, here two terms are multiplied with the same base. So what we can do is we can write the base ones and we can add the exponents using the product rule of exponents. And the complete stuff has to be raised to the power of x. Okay, now we have 2 to the negative 8th power equals to, now we have to simplify this 1 positive 1 over 2. Here we are adding an integer and a fraction. Whenever I add an integer and a fraction, I have to multiply the integer by the denominator of the fraction. Once I'm done with the multiplication, I can take this 2 as a common denominator. Okay, now let me multiply this integer 1 by this denominator 2. That is 1 times 2 is 2 positive 1. Now we can take the 2 as a common denominator. It has to be raised to the power of x. Now we have 2 to the negative 8th power equals to 2 to the power of, so 2 positive 1 is 3, that is 3 over 2, or raise it to the power of x. 2 to the negative 8th power equals to, here we have base 2 and we have exponent 3 over 2, and for this complete stuff we have the exponent x. Whenever we have two exponents like this, what we can do is we can multiply the two exponents, then I'm getting 2 to the power of 3x over 2. When I multiply this 3 over 2 and x, I'm getting 3x over 2. Okay, here, consider the stuff we have on the left side, that is 2 to the negative 8th power, and consider the stuff on the right side, that is 2 to the power of 3x over 2. On both sides, we have the same base. Whenever two terms are equal with the same base, what we can do is we can equate the exponents. Then I'm getting negative 8 equals to 3x over 2. Okay, now in this equation, we have to solve for x. First, let me get rid of this 2. For that, we have to multiply both sides of the equation by 2. When I do so, this 2 will cancel out. 2 times negative 8 is negative 16 equals to 3x. Okay, now let me divide both sides of the equation by 3. When I do so, this 3 will cancel out. I'm getting negative 16 over 3 equals to x. I got the value of x. The value of x is negative 16 over 3. Actually, we have assumed this x as the value of the given logarithm. Therefore, the value of the given logarithm is negative 16 over 3. We find this negative 16 over 3 in answer choice D. The correct answer choice for this question is D.